Hi, my name is Atsushi Marui. I will be presenting the feasibility study on evaluation of different music styles using the multi-stimuli ideal profile method. Background music played in commercial venues is often used to define the mood of the venue, but also affects the emotion of the hosts and guests. There are several ways to evaluate such music pieces. Rate each piece with attributes such as bright and strong. Rate the amount of difference between two pieces, or choose which of the two is preferred. However, rating with one or two pieces at a time will introduce inconsistency across ratings. Also, only music pieces used in the experiment are rated. Hence, we propose the use of the multi-stimuli ideal profile method, MSIPM. The ideal profile method, IPM, is a subjective attribute rating method that includes the most ideal stimulus in the list of stimuli. The ideal stimulus is not presented as the actual sensory object, but rather participants are asked to imagine and rate the given attribute as if there is the ideal stimulus. A variation of IPM, known as the multi-stimuli ideal profile method, involves the simultaneous comparison and rating of multiple stimuli on a single attribute during a trial. Authors have seen it used in foods and cosmetics, but can it be used for rating music? To check whether MSIPM is applicable to evaluate music pieces, we prepared 3 songs with 8 arrangement styles, including one virtual style for the ideal stimulus. 3 songs were chosen from jazz standards, namely Autumn Leaves, Misty, and T for Two. 32 bars of chord progressions without melody were used with a fixed tempo of 120 beats per minute. Arrangements included the shown 7 actual styles and 1 ideal style. Rating attributes were taken from the work by Taniguchi on relating musical impressions to emotion. All attributes were presented to participants in Japanese language, and the author's best translations into English are shown here. Participants were asked to listen to arrangements using the app shown below. After clicking on A, B, or C to choose a song, participants were able to switch between 7 music styles. They were asked to rate each stimulus on an 11-point scale from 0 to 10 on given attributes. A sample response sheet is shown on the right-hand side. Rows indicate attributes and columns indicate 7 actual arrangement styles and 1 ideal arrangement style. When ratings of one song was completed, participants proceeded to the next song. The order of the songs is counterbalanced between the participants. Total of 11 university students and postgraduates took place in the experiment. Each person underwent the experiment individually and took about 90 minutes to complete the tasks, including instruction and debriefing sessions. Principal component analysis was applied per participant. PCA can reveal the relation between attributes, the relation between stimuli, and the relation between attributes and stimuli. Here, results from participant number 4 are shown. The left figure shows attribute space, where stimulating and casual are pointing towards the left, and depressed, calm, and tender are pointing towards the right. The two axes may be related to the valence arousal emotional system proposed by Russell and Barrett. The figure on the right shows stimulus space. A, B, and C show 3 songs, and numbers from 1 to 7 represent arrangement styles. AID, BID, and CID are ideal stimuli. Magenta symbols are average configuration of corresponding stimuli. We can see that stimuli are roughly grouped by arrangements rather than songs. We can overlap 2 figures to see the relation between attributes and stimuli. We can see, for example, stimulus A3 on the right is located at depressed, noble, and serious. On the opposite side, stimulus B7 can be explained to have a caprice and stimulating character. Since some participants were not able to fully use the attributes, multidimensional scaling was applied on Euclidean distance between raw ratings from all participants to find the individual differences between participants. In the figure, participants rated similarly are placed close to each other. Symbol colors indicate which grade they are in. Because participants 1 and 10 on the right are placed farther apart from the other participants, those 2 first-year students seem to be outliers. For example, let us look at the rating sheet of participant 1. This participant rated all arrangements to 0 on serious and noble attributes. Participant 1 seems not being able to distinguish the arrangement styles using these 2 attributes. After excluding the outliers, group configuration can be obtained by applying PCA on average ratings. Although it eliminates individual differences, we can see that there are 2 groups of arrangement styles, and the ideal arrangement is configured in the middle upper position within the larger group. Because ideal stimuli are configured closer to arrangements 1, 2, and 6, we may be able to tell a human arranger to use them as a point of reference when we want to further arrange the songs. Through this feasibility study, it was shown that MSIPM was applicable to evaluate arrangements of music pieces. However, experiences in participating in experiments and fluency in attributes affected the ratings. Also, ratings may depend on where in a song that participant was listening within a minute of duration. Some participants had difficulty using attributes serious and noble. This may be due to that they came from a classical music context, and those attributes may not have been appropriate for jazz arrangements. The difficulty of the experiment was not a problem for most of the participants, thus making MSIPM one of the attractive options for conducting a music listening experiment. Thank you for watching the video.